We're going to have a look at alternative methods for solving and factorising quadratic equations. So, for example, completing the square and the quadratic formula. Now, the usual method might be to solve using factorisation. So, for example, with question 1, we have x squared plus 8x plus 16 equals 0. So what you might do is you might think about the factors of 16. And this was covered in the video on factorising quadratic equations. 1 and 16, 2 and 8, 3 is not a factor, and then we'd have 4 and 4. And we repeated ourselves because we had 4 twice. 4 times 4 is 16. So we've completed our list of factors. Because we know that these factors are going to multiply together to make 16. But they also have to add together to make 8. So now we look at which ones could add together to make 8. Now, 1 and 16 are not going to make 8. 2 and 8 are not going to make 8, but 4 and a second 4 could make 8. So to factorise, we have a double bracket of x in both because x times x makes the x squared, and we're going to want plus 4 in both. The two 4s add together to make 8, and they multiply to make the 16. So when we say this equals 0, we want to make the brackets equal 0 because you multiply by 0, you get 0, and these brackets are multiplying each other. So if x was negative 4, that would make the brackets equal to 0. So we've solved the quadratic equation. Now, of course, we've already covered this, so let's look at the alternative method, completing the square. So let's hit the same question. X squared plus 8x plus 16 is equal to 0. And in this method, what we're going to do is we're going to have the x term. So that's going to give us x plus 4, and that's going to be squared. So kind of look what I've done here. So the x squared has become an x. The 8x has been halved to a 4, but we've left off the x variable. Now, why have I done this? Well, let's look at what happens when we expand that bracket. So we've got x plus 4, and it's squared. So there's two of them. When we expand this, we're going to have x multiplied by x is x squared. X multiplied by 4 is 4x. 4 multiplied by x is 4x. And 4 multiplied by 4 is 16. Now, collecting the like terms, we've got two 4x's in the middle. That means we've got an x squared term. We've got 8x altogether, and we've got plus 16. Now, comparing that to our original equation, multiplying out those brackets has given us the x squared term and the 8x term. So that's great. But what's gone wrong here is that we have this plus 16. Now, we actually haven't done anything with the plus 16 that was in the original question. That's not been used yet. But now we've got an extra plus 16. So we have to do something about that. And since there's an extra plus 16, we can take that 16 away. Then we've got the plus 16 in the original question. That's still there. And so we get something like this. Now we can cancel out those whole number terms. They don't always make 0 like this one. But in this case, negative 16 plus 16 is 0. So we've got x plus 4 squared equals 0. And you can see we've got the same factorisation that we had in the first question when we looked at factors. I've just written a different way. So rather than writing x plus 4, I've written x plus 4 squared. To solve it, we still need to make the bracket be 0. So if x was a negative 4, then the bracket would be negative 4 plus 4, which is 0, and 0 squared is 0. So we've got the same answer by completing the square. So let's try that method with question 2. So we have x squared plus 2x take away 80, and that is equal to 0. So in our method, we're going to have the x terms. So we're going to have x plus 1. So looking at that again, the x squared has become x. The 2x, I've halved the 2 to get 1, and I've left off the x variable. That gives me x plus 1. It's going to be all in brackets with a squared symbol because we've got to multiply this out to get the x squared. Now, like in the first example, this isn't going to be 100% accurate. And that's because, again, if we look at expanding the brackets, x plus 1 squared, x times x is x squared, x times 1 is 1x, 1 times x is 1x, and 1 times 1 is 1. And collecting all that up, our x squared plus 2x plus 1. Now, the x squared plus 2x looks exactly like my question. That's absolutely fine. That's what I wanted. but we've got this extra plus 1. So because we've got a little bit extra, we're going to have to take that away. So over in my equation, I'm going to take 1 away, just to cancel out the extra plus 1 that I'm going to get. Once I've done that, the negative 80, I've not actually used that yet. I've not taken that into account when I made my brackets. So the negative 80 is still there. And all of that is equal to 0. So combining the two number terms, so we've got a negative 1 and a negative 80. So altogether, that's going to be a negative 81 equal to 0. Now, unlike the first question, this hasn't cancelled out to give us a 0, so we've still got that negative 81 there. So what we're going to have to do now is solve the equation like you normally would. So we're going to move the 81 to the other side. So add 81 to the left and add 81 to the right. And this is going to give us the bracket we haven't moved. Negative 81 and positive 81 have cancelled out, they've gone. That's why we did it. And 0 plus 81 is 81. The next step, and remember solving equations, try to get x on its own. It's contained in a bracket, it's being squared, so we need to square root that bracket. And if we are square rooting the left, then we also need to square root the right. So a squared and a square root cancel out, bracket is gone. And 81 squared, well, luckily 81 is a square number, 9 times 9 is 81. So 81 rooted is 9. Now we've got a very simple equation to solve. We can take 1 away from both sides, and that leaves us with x is equal to 8. Now, that looks okay for an answer, but you might have spotted something. Perhaps you're thinking, well, this method, what's the point in using it? It looks quite complicated, not quite understanding what's going on here. I can just factorize this. And if we have a look at the original question, some of you might have thought, well, okay, we're going to need double brackets. I want two numbers which multiply together to make 80 and add together to make 2. We already know that 8 is going to be in there. So what's the other one going to be? Well, to make negative 80, that would be negative 8 times a positive 10. And so there we have the factorization. If you add the two numbers together, 10 take away 8 is giving us a 2 for the 2x. And the 10 times negative 8 is giving us a negative 80. So looking at completing the square, we've only got one of the answers. We only actually got the 8. We didn't get the 10. So how do you get the 10? Well, the whole thing with this is when I square rooted the 81. And it's all about what actually is the square root of 81. And it's not necessarily going to be 9. Well, what does that mean? Square root means that 9 times 9 is 81, so 81 rooted is 9. But there's another way to get 81, and you can do negative 9 times negative 9 is 81. So there's an alternative answer. We could also have, at this x plus 1 stage, that is equal to negative 9, because that is an alternative answer to rooting 81. Now, if we had negative 9 instead, we are still going to take away 1 from both sides, and that will leave us with x is equal to, and negative 9 take away 1 is going to give us negative 10. And that's how we get in the 10 in the brackets if you did this using normal factorization. So when we're completing the square, we always have to think, if we are going to do a square root, and we usually will be, then there's going to be a possible negative answer to look at. So now we've gone through how this works, let's look at a question how we would normally do it. So we've got x squared minus 2x minus 3 is equal to 0. So using the completing the square method, open up our brackets. We're going to have the term, so x squared is going to be x, and then negative 2 is halved to give us negative 1. Then we have to think, by doing this, there is going to be an error. And the error is when you multiply the numbers out, we're going to have a negative 1 times negative 1 term, which will give us a positive 1, and we don't want that extra positive 1, so we're going to take it away. So again, how have I worked that out? I've just looked at the number, and I'm not going to write out the brackets and multiply out all 4 terms, because I don't need to do that. I know it works for the x terms. I know the fourth term, we'll do negative 1 times negative 1. That's going to give me positive 1. I have to compensate for it by taking 1 away. Then we haven't done anything about that negative 3. That is still there. Let's collect up what we've got. Negative 1 take away 3 is negative 4. And now we are going to solve the equation. Now I'm not going to write in the step-by-step steps here. I'm just going to read it out, so pay attention. So we need to add 4 to both sides to get the bracket on its own. We are going to square root both sides. The square root will cancel out the squaring, and the square root of 4 is 2. But remember, yeah, it could be a positive 2. 2 times 2 is 4, but also negative 2 times negative 2 is 4. So there could be a negative 2 as an answer. And we can write both at once just by writing the plus and minus symbol. Next, I'm going to add 1 to both sides. So our positive or negative 2 is going to have a 1 added to it. So now we look at both alternatives to work out our final answer. So x could be, it could be a positive 2 plus 1, which would be 3. But x could also be, it could be a negative 2 plus 1, which would be negative 1. And so we've got both possible answers. Checking your work, see if those would work in double brackets to make our original expression. So we'd have x minus 3 in a bracket, and it's going to be the opposite because we're making 0 to get our x answers usually, and negative 1 will become a positive 1. So would that multiply out to make our expression? So x times x is x squared, that works out. Adding together negative 3 plus 1 will give us a negative 2, or negative 2x, that works out. And negative 3 times a positive 1 will give us a negative 3, so that works out. So it looks like we've got the correct answer. Let's try question 4 with the same method. So we have 2x squared, take away 8x plus 6 is equal to 0. Now, the completing the square method only works if the coefficient on the x squared is a 1, and we've got a 2 there. But it's a really easy fix. All we're going to do is take 2 out as a factor, and then we're going to ignore that 2. So 2x squared divided by 2 will be 1x squared, which is what we need to complete the square. Negative 8x divided by 2 would be 4x. 6 divided by 2 would be 3. Then it will close that bracket, and that's going to be equal to 0. And for now, we're just going to ignore that 2 and pretend it's not there and continue as we normally would. So we are going to open up our bracket. We're going to have the terms. So negative 4 is going to become negative 2. And then we have to make our correction because a negative 2 times negative 2 will give us a positive 4. And we don't want the extra positive 4. We're going to have to take that away. And we've also got the plus 3 that was originally there in the first place. Once I've done that, let's put that 2 back in. And you can see I've got 2 sets of brackets. I've got the blue set of brackets and the pink set of brackets. Now I can color code this on the computer so you can see the difference. But if you're writing a pen and paper, you've got a one color pen. A square bracket is a good way to tell the difference between a different set of brackets, one square and one curly. And now collecting up our numbers, the bracket's fine as it is. And negative 4 plus 3 would be a negative 1. So now we've completed the square, we can now deal with that 2. I'm just going to multiply everything by 2 and get rid of that set of brackets. So we'd have 2 lots of our inner bracket. Negative 1 times 2 will be negative 2. And now what we can do is start to solve the equation like we were before. So my first step might be to add 2 to both sides, get the bracket on its own. I might want to divide the bracket through by 2 to get rid of the 2 at the front. So having 2 lots of the bracket, I've now got 1 lot of the bracket. But if I divide the left by 2, I need to divide the right by 2 as well. 2 divided by 2 is 1. Then we're going to do the square root. That will cancel out the squaring of the bracket. And the square root of 1, remember, 1 times 1 is 1, but also negative 1 times negative 1 is 1. So it could be a positive or a negative 1. Could be either, so we're going to have 2 different answers taking that into account. So now we're going to add 2 to both sides. X is going to be either a positive or negative 1 plus 2. We'll look at both alternatives for our answer. If it was a positive 1, we'd have 1 plus 2 is 3. But it was a negative 1, we'd have negative 1 plus 2, which is going to give us a positive 1. Finally, to check our answers, we can see if they're going to work in a factorization to get our original expression. So if we had our double brackets, and we'd add x in both, and we're going to have the 3 and the 1 in there as well, and there'll be a negative 3 and a negative 1, because it's going to be the reverse to make the brackets equal 0. Now, those 2 brackets are not going to multiply out to make our expression. So do we have the wrong answer? Well, we don't, and the reason is because we haven't included the 2x squared. This brackets are going to multiply it to make a 1x squared. So we have to put the 2 in there as well. Now, for this question, the 2 is going to go in the first bracket, And then what's going to happen is, because I've got the 2 in there, I'm going to have to make the -3 twice as big to make up for it. And that'll give us a -6 instead. And now if you multiply this out, -6 times -1 is going to give us a +6. That works. Then we're going to have the -6 times x for -6x. And we need 2 more to get down to -8. And that's going to be the 2x times -1. So that's going to work. And then the 2x squared, 2x times x is going to give us 2x squared. So now this multiplies out to give us the correct expression. But you might be thinking, hang on a second, I've got a 6 in there now, but I've got a 3 in my answer. How does that work? Well, again, it's all about making the brackets be equal to 0. Now you can make the second bracket be equal to 0 by putting the 1 in there. 1 take away 1 is 0. And no matter what the first bracket is, you multiply them by 0, you're going to get 0. Looking at the second bracket, if we put a 6 in there, because it's got that 2 in there, it's multiplying by 2. So you'd have 2 times 6 is 12, you're taking away 6, and you're not getting 0. But if you put the 3 in there, 2 times 3 is 6, take away 6 is 0. So while the factorization has a 1 and a 6 in there, the answer is going to be a 3 and a 1, because the number has to be divided by the coefficient on the x. So we do have the correct answers, 3 and 1. Now looking at the final easy question, we have 3x squared plus x, take away 14, is equal to 0. Now it's quite a tricky question this, because the first thing we need to do is deal with 3x squared. We only want 1x squared for this to work. So we're going to take the 3 out and we're going to factorize everything. So 3x squared divided by 3 is x squared. 1x divided by 3, well, that's not a nice thing to do, is it? So all you need to do is don't bother dividing it by 3. Just write the x in, write it over 3. Yeah, the answer is a third. You could write a third if you wanted to, but it's just easier to leave the divide in there. And the same thing with the 14. Why bother dividing it by 3 when you can just write 14 over 3? Much easier. What we're going to hope is that later on, something's going to happen that will make those fractions nicer for us. So we're not going to work them out just now. Now we've done that, we can follow our method. So we're going to open up our brackets and we are going to halve the x term. So if it's been divided by 3, so it's a third, then half the third would be a sixth. Now it's unfortunate that's a fraction, because then we have to make our correction. And it's when the kind of number term is multiplied by itself. So it's going to be when a sixth is multiplied by a sixth. And if you think about multiplying fractions, multiply the numerators and the denominators, a sixth multiplied by a sixth would be 1 over 36. And that's going to be positive. So we need to take that away to make up for it. And then we're going to be taking away the 14 thirds as well. And then remembering all of that is in brackets with 3 taken out as a factor. Now we have the difficult job of dealing with the fractions. This will be actually quite a high level question, given the difficulty of it. Remembering everything is going to be in the brackets. And what we want to do to sort out these fractions is make the denominator the same for both fractions. So let's make the denominator be 36. So if we've got 1/36 and we want to make something over 3 be out of 36, we need to make that denominator 12 times bigger. So 3 times 12 is 36, but I'm going to have to do 14 times 12, which is going to give us 168. Now we can combine those two terms together. So -136 take away another 168. Altogether, we're taking away 169 lots of 36. And again, let's just write in the rest that we've not used yet. Next step is going to be to multiply everything through by 3. So we're going to have 3 lots of the bracket. And we have a -169 over 36. If we're going to make that 3 times bigger, then we're going to divide by something that's 3 times smaller. So that's going to be over 12 now instead. We're then going to move that to the other side, giving us 3x plus 16th squared is equal to 169 over 12. Now we've got 3 lots of the bracket. We just want 1 lot of the bracket. Let's divide 3 by 3. So that will give us just 1 lot of the bracket left. But we divide the left by 3, we have to divide the right by 3. So we want to make 169 over 12 3 times smaller. We need to divide by something 3 times bigger. 12 times 3 is 36. So we're back to 169 over 36. Now we're going to square root both sides. That's to get rid of that squared bracket. you might have noticed the fraction is made out of square numbers, and we can square those individually. So 169 rooted is 13, 36 rooted is 6. So that gives us 13 over 6. So that fraction has almost sorted itself out now. And remember, that's assuming a positive version of that fraction is multiplied by itself, but you can also have a negative version of the answer as well. So now we're going to take away a sixth from both sides. That'll give us a positive or negative 13 sixths. Take away another sixth. So then trying to resolve that, if we have a positive 13 sixths, take away sixth, that is going to give us 12 sixths. And 12 sixths is the same as 2. 12 divided by 6 is 2. If it was a negative 13 sixths and we take away another sixth, that'll give us a negative 14 sixths. And converting that into a mixed number, 14 divided by 6, well, you can take 2 whole sixes out of it. You can have 2 left over, which would be 2 sixths, which is the same as a third. And then just remember the whole thing was negative. So x is either 2 or negative 2 and 1/3. Now, that's the answer, but we want to check our answers. And we think about, well, how would this factorize? We're going to have 3x and x to make 3x squared to make our original expression. And then one of our two numbers is going to be multiplied by 3. And I'm guessing it's going to be the 2 and 1/3. 2 and 1/3 multiplied by 3. Well, 2 times 3 is 6. A third times 3 is 1. 6 and 1 is going to give us 7. And then they're going to have the 2 in the other bracket. And again, the signs are going to be flipped because we're trying to make the brackets equal 0 when we're factorizing. So is that going to multiply out to make our original expression? Well, a positive 7 times negative 2 will give us negative 14. That works. 3x multiplied by x gives us 3x squared. That works. And then what's going to happen is we multiply this out. That negative 2 will be multiplied by the 3 to give us a negative 6. The 7 will multiply by the x. So a 7x take away 6x is going to give us a single x. So it looks like we've got the right answer. Now, you might be thinking, what is the point of the completing the square method? Because it's very complicated. The last question filled up the entire page, and you can just factorize using factors. So why do we need to do it? Well, moving on to the medium questions, we're going to get some questions now that you can't factorize just using double brackets, trying to think what multiplies and adds together. So this is an example of a question where completing the square might be the only way of doing it. So let's look at question 1. So we have x squared plus 6x plus 2 equals 0. And as I mentioned, if you try and get some double brackets, you got x and x in there, and you're going to think, right, okay, how do I get two numbers which multiply to make 2, add together to make 6? Well, there's only one way for 2. You can only get 2 by doing 1 times 2. But there is absolutely no way to get 6 out of that. We're going to get a 3. So we can't actually factorize using this method. However, if you complete the square, so let's put down our brackets. We're going to have 6x to give us 3, and then we're going to correct it because these brackets will multiply out, and the 3 times 3 will give us a 9. So we need to get rid of that 9. We don't want it. And we have to add on the 2 that was there from the start. Collect up those terms. Negative 9 plus 2 would be a negative 7. And now let's try and solve this. So let's move the 7 to the other side by adding 7 to both sides. Let's square root. So that'll get rid of the squared because it's the opposite of it. And then square root in the 7. 7 is not a square number, so how do we square root it? Well, we could write a decimal, and that is an option for some questions. But if you can't square root a number, just leave it in a square root symbol. And what we have now is we have a surd. And it's just a way to not write that decimal down. We have an accurate answer. It's just not as you'd normally expect it as a decimal. And again, as usual, you can have a positive or negative alternative to that. Then our last step will be to take the 3 away from both sides. And so x is going to be a positive or a negative root 7 taking away a 3 at the end. And that is your answer because it says in the question, solve it and write it in surd form. And you have a surd. So it's absolutely okay now to leave the answer like this. You don't need to work out the root of 7. And going back to what I said at the start, there is no way you're going to be able to write double brackets that have got a surd in it and have it make sense to you. So this is not something you can solve with normal factorization. So this is why we have to use the completing the square method. So let's look at another example. So question 2, we have 8x squared, take away 3x, take away 8 equals 0. So we are going to complete the square, open some brackets, and half the term on the x. So negative 3 is going to become negative 1.5. Now we're going to have to make a correction here because negative a half multiplied by negative a half is going to give us 2.25. So we have to take away that 2.25 to make sure it's not there. Then we've got the negative 8 and we are equal to 0. Collect up the whole numbers. So negative 2, take away another 8 is going to be negative 10. And we've got that quarter on there as well to be negative 10.25. Then we're going to solve the equation. So let's move the 10 over to the other side. Again, not forgetting the quarter. And then we're going to square root both sides. That'll get rid of the bracket. And we want the square root of 10.25. Not something we're going to be able to do, so we'll just leave it like that. Remembering we can have a positive or negative version of that. Then we're going to add the 1.5 to both sides, which will give us a final answer with a plus or minus 10.25 plus 1.5. Now, that's fine as an answer, but that 10.25 looks a little bit messy. So what can we do about that? Well, if we write it a different way, we could convert it all into an improper fraction. And we could say 10 written in quarters would be 40 quarters. And the extra 1/4, so that would be 41 quarters over 4 as an improper fraction, plus the 1.5. Now, what you can do here is you can root the numerator and denominator separately. And we're not really going to be able to root that 41, but we can root 4. So what we could end up with as a final answer is x is equal to plus or minus, and we could say the root of 41 over 2, because root 4 is 2, plus, and we could write 1.5. Alternatively, you could write 3 over 2. And now we've got an answer that looks a little bit shorter. Now, any of these answers should be absolutely fine unless the exam paper specifically asks you to write it a certain way. An exam paper might say write it in a form where it's a square root over a number, and that's where that final one's going to get you an extra mark. But it doesn't say that, then your root 10.25 should be fine. But what you'll probably find is questions will be designed to not leave you with numbers like that. Moving on to question 3. So we have 2x squared plus 8x plus 2 is equal to 0. Remember, we need to take that 2 out as a factor because we need this to be a 1x squared term for completing the squared to work. So dividing everything by 2, 2x squared divided by 2, 8x divided by 2, and 2 divided by 2. Completing the square there is going to leave us with x plus 2 in the brackets because the 2 is half the 4. But 2 times 2 will give us 4, and we have to correct that, so we're going to have to take away 4 at the end. Remember, adding the 1 as well, that needs to still be included. And then at the end, we can just include that extra set of brackets with the 2 we took out as a factor. Now let's multiply everything through by that 2. So we're going to have 2 lots of the bracket. The negative 4 plus 1 is negative 3. So we multiply that by 2, we'll have negative 6. And that's going to be equal to 0. And then for our next step, we can do a variety of things here. So we could, for example, put the 6 over to the other side by adding 6 to both sides. And then we can divide through by 2, which will leave us with a 3. Then we're going to square root. That'll get rid of the square brackets for us, but we're going to have to square root 3, which we can't do. It's not a square number. And we don't need to use a calculator here. We can, again, leave it as a third, leave it as root 3. It's an accurate answer. If we wrote it as a decimal, we need to round it because it's a rational number. Those numbers keep going, and that's going to leave us accuracy issues. But do remember that positive root 3 times root 3 gives us 3, but also negative root 3 times root 3 gives us 3. So we've got a positive and negative alternative. Then we can take away 2. So x is equal to positive or negative root 3 take away 2. Moving on to question 4. We've got 3x squared minus 11x plus 5 is equal to 0. So again, the first step is to take out whatever number is on the x squared as a factor because we need that x squared term to have a 1 on there for completing the square to work. So divide everything by 3. And again, you don't need to divide 11 by 3. Just write the sign there. And the same thing with 5. You don't need to divide it by 3 and write a decimal. You just write 5 over 3. And then hopefully later on, we can multiply through by 3 again and get rid of those fractions. So now we can complete the square. So we're going to write our brackets. And we need to find half of 11 over 3. And when we find half of the fraction, what you can do is you can double the denominator. So 11 over 3, half of that is 11 over 6. But again, we're going to have to correct that. So we need to do 11 over 6 multiplied by itself. So let's leave a bit more space. Let's get rid of that bracket. So multiply a fraction by itself. Multiply the numerators, multiply the denominators. 11 times 11 is 121. 6 times 6 is 36. Now, a negative times a negative is going to give us a positive version of that. So to get rid of it, we need a negative version. And then we're going to add on the 5/3. But let's just turn that into something with 36 straight away to help the next step. Because we're going to have to combine these fractions together. So if the denominator is 3, I want it to be 36, I'm going to multiply by 12. So 5 times 12 is 60. 3 times 12 is 36. And it's all equal to 0. So then when we combine those two fractions, we have negative 121 over 36. We have positive 60 over 36. Altogether, that'll be a negative 61 over 36. Then again, remember, we have the other set of brackets, and we are equal to 0. So then next, we can multiply through by 3, giving us 3 lots of the bracket. Our fraction, if it's over 36 and we're making it 3 times bigger, then we want something 3 times smaller, so that would be 12. I'll just move that over to the other side to save a step. But then we want the bracket on its own, so we're going to divide through by that 3, leave us with one set of the bracket, and leaving our fraction going back to the 36. Now we need to square root. On the left, that'll get rid of the bracket, the squared bracket. And on the right, we can square root the numerator and the denominator separately. So we're going to square root the 61, and the square root of 36 is 6. As usual, remembering that could be positive or it could be negative. So then looking at our final answer, we've got x. It's plus or minus the square root of 61 over 6. And then when we bring the 11/6 to the other side by adding it, we're adding on the 11/6. Moving on to question 5, we have 5x squared plus 9x minus 1 is equal to 0. And as usual, our first step is ensuring that we have 1x squared. So we're going to have to divide the whole thing through by 5 to get that. 5x squared divided by 5 is 1x squared. That's why we did it. 9x divided by 5, well, we can have 9/5 x. So we're not actually doing the divide by 5. And the same thing with the minus 1. Just write it over 5. We're not doing the divide by 5, but we're writing it into the equation so we know that it's there. Now we can complete the square. So set up our bracket. Half of 9/5 would be 9/10. And then we have to make our correction. So 9/10 multiplied by 9/10 would be 81/100. So we've just multiplied the numerator by itself and the denominator by itself. That's going to be positive in the expansion, so we have to take it away to make our correction. Also taking away the 1/5, but I'll write 1/5 as something over 100 to help the next step. So 1/5 times it by 20, that'll give us 20 over 100. That's equal to 0, and don't forget the other set of brackets, the 5 that we took out at the start. So now let's multiply through by 5 and collect up the fractions. So we'll have 5 sets of the bracket. Negative 81, take away another 20, would be negative 101. And that should be over 100, but we're making it 5 times bigger. So to make the denominator 5 times smaller, that'll give us 20. So again, dividing by a smaller number means that we've got a larger number, and that's equal to 0. And then at the same time, we can add the 101 over 20 to both sides, and that's just going to make it change sign and change sides. Then we can divide everything by 5 to get the bracket on its own, which will put our fraction back to 101 over 100. You can divide it by 5, we're going to make the numerator 5 times bigger, and then the bracket's squared, so our next step is the square root. So x plus 9/10 is equal to, let's say plus or minus, the square root of 101 over the square root of 100 is 10, so we can write it like that. So for our final answer, we can write that x is equal to plus or minus 101 over 10, and then move the 9/10 to the other side, it'll be take away 9/10. Now, there's one other way to solve quadratic equations, and this is what it looks like. So x is equal to negative b plus or minus the square root of b squared minus 4ac, with the square root covering all of that, and then everything we've already gone through is being divided by 2a. And this is called the quadratic formula. Now, it's a bit of a nightmare to remember, but it's something you're going to have to try and memorize so you know so you can use it every single time. And what does the A, B, and C mean? Let's color code this. So firstly, the A is referring to the x squared term. And if there's no letter on it, that means that A is equal to 1. So every single time you see an A in the quadratic formula, you're going to use whatever number is there. And if there's no number, it's going to be a 1. So that represents A. B is the number on the x with the sign before it as well. So in question 1, that is a positive 4. So every single time you see a B in the quadratic formula, for that question, you're going to substitute in a positive 4. And then the C, it's kind of predictable now, that's the next number. That's just the whole number term at the end. Again, it includes the symbol before it, so that's a positive 4. So every time you see a C in there, there's only one. What you do is you write out the quadratic formula another time, but you swap all the A, B's, and C's. So, for example, negative B at the start, B is a positive 4. So swap that in for a 4. We've got the plus or minus. We've got a large square root symbol. And then we come across another B, and it's being squared. So that's going to be 4 squared. Then we're taking away 4 multiplied by A. Now there's no number there, so A is 1. And then it's being multiplied again by C. And C is a positive 4. Remember, when you have letters next to each other, they're being multiplied. And that's the same at the bottom as well. Letters and numbers next to each other. That'll be a 2 multiplied by A, and A is 1. Now, that still looks like a mess, but it is something you can now start to work out. Now, the best way to do this is to work it out in a few separate parts. So let's look at the square root part of this first. So in the square root, we have got 4 squared, and that's going to give us 16. And then the takeaway section of this, it's 4 times 1 times 4. 4 times 1 is 4, 4 times 4 is 16. Now we take the square root section. Remember, we have the minus 4 at the front, and it's all being divided by 2 times 1, which is 2. Then we can clean this up by solving the square root part. 16 take away 16 is 0. The square root of 0 is going to be 0. That leaves us with x is negative 4 over 2, and that's going to give us 4 divided by 2 is 2. So x is negative 2. So this one's only got one answer because the square root section turned out to be a 0. Now, like before, you can think about checking your answer. So if x is negative 2, my double brackets are going to be 2 sets of that. And it's going to be the opposite of negative 2 because the bracket's going to end up being 0 to make this work. Does that multiply out to give us our first question? So x times x is x squared. X times 2 is 2x. And 2 times x is 2x. And 2 times 2 is 4. Giving us x squared plus 4x plus 4, which is our original question. So working backwards, we've got back to our question. So we know we've got this right. So now moving on to a more difficult question. With question 2, always start these questions by writing down the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac. Cover the whole thing with that root sign and then divide absolutely everything by 2a. And then your next step is you're going to write down the formula again, but you're going to do your substitution. And even if you make a mistake with this very difficult calculation, you still get some marks by showing that you know the formula and you know to substitute. So identify A, B, and C. A is the x squared term, So A is 1 because there's no number there, so we just assume it's a 1. In algebra, we don't write the multiply by ones. B is going to be negative 10, so it's the term on the single x, include the sign before it. And then this one's been rearranged, and there's nothing there for the plus c, but it's not equal to 0. So the c section is going to be covered by the 4. Well, because it's on the wrong side, we need to move it back to where it should be. So if you take away 4 from each side, you're going to end up with a c is equal to negative 4. So just watch out if you need to rearrange. Really clear, the rearrangement would be x squared minus 10x, and it would be minus 4 is equal to 0. So now you've done that, substitute in. One way to do this is to first draw out all the things that are not going to change. So it's going to be 2 multiplied by something. It's going to be negative b, leave a space for the number, plus or minus the square root of something, and there'll be a takeaway in there as well between the terms. Now I'm going to work our way through. Let's substitute in the b's. So we're going to have a negative 10 for that b and a negative 10 for that b. And I've not written in the it's squared, so let's do that. Substitute in the a's. A is 1, so we have an a at the bottom, and we have an a multiplying the 4 underneath the root sign. Substitute in the c's. There's only one c at the end, multiplied by the negative 4 for c. Let's just extend the root symbol and the fraction to make that really clear. So you can see that we have exactly the same layout, but all we've done is swap the b's for negative 10, swap the a's for a positive 1, and swap the c's for a negative 4. So let's work it out one pair at a time. Negative 10, that's going to give us a positive 10. Then let's do the square root. Negative 10 squared, negative 10 times negative 10 will be a positive 100. Then work out the subtraction section. So 4 times 1 is 4. 4 times negative 4 is negative 16. You've got to be really, really careful here as well, because we've got so I've got the negative symbol that's included in the equation anyway, and then another negative symbol from the negative 16 when I did 4 times 1 times negative 4. Then we can do the bottom. 2 times 1 is 2. So I kind of did that in 4 sections. I dealt with the minus b on the outside first. Then I dealt with the b squared underneath the root. Then I dealt with the 4ac under the root. And then I dealt with the 2a. We can start to solve this now. X is going to be equal to 10 plus or minus. Now under that root sign, I've got 100 take away negative 16. So that's going to be the square root of 116, because a double negative is going to make a positive, and it's all divided by 2. Now, if I were to leave that in third form, that would be okay. And maybe I could do something like divide the 10 by 2 to get 5, write the root 116 over 2, but I've been asked to write it as a decimal. So now this is actually going to go into a calculator to work out a proper final answer. So on a calculator, you can have 2 different alternatives. What could happen? We could have x is equal to, and we could have 10 plus the root of 116. And then we want to divide all of that by 2. So on a calculator, you could put that in brackets and divide by 2. The other alternative is to have exactly the same thing, but it's a negative 116. It's all divided by 2. And you can use divide by 2 there, or you can use the fraction symbol and write the 2 underneath a fraction, whatever you're most comfortable with. So let's type that exactly into a calculator. 10 plus root 116, close the bracket, divide by 2. And I'm getting, as an answer for my first answer, 10.385. Now, I'm going to stop after 3 decimal places. It's a third, it'll be an irrational number. That decimal will go on forever, so I'm just rounding it off after 3 decimal places. The question's not told me what to round to, so that should be a safe place to stop. Maybe I could do 2 decimal places and write 10.39. And then the second one, what you can do is look at your calculator display, press the back button, go back to the plus, and change it into a minus, and then press the enter key. And without typing it all in again, you should get another answer, and that's negative 0. And we'll do 3 decimal places again. 385. So kind of coincidentally, we're kind of seeing the same decimals repeat there. But again, if you look at what you've done, there is a pattern between those two, which is a plus or a minus. So maybe it does make sense that you're going to get similar decimals. Moving on to question 3. So again, we're going to start off by using substitution. write in all the things that are going to stay the same: the minus, the plus and equals, the square root sign, the squared sign, the takeaway, the 4, and that's all over 2 times something. So let's look at what we've got. So the A is A2. So we can look over, and anywhere we see an A, we can swap with a 2. So it'll be 2 times 2 at the bottom, and it'll be 4 times 2 under the root sign. Then we can look at the B. The B is a positive 6. Anywhere we see a B, we can swap with a 6. So at the start and under the squared symbol. And then finally the C. Now again, this has been rearranged, so it's actually 2x squared plus 6x. C has to be on the same side. So we move the 10 over by taking 10 away from both sides, making it equal to 0. Now we can see that C is actually negative 10. Always be careful that the equation is written in the correct format. If it's not, you will need to rearrange. So anywhere we see a C, we can swap with a negative 10. And then we're going to do 4 calculations to simplify this. Firstly, we're going to look on the outside. Now, if the negative B, it's just negative 6, so there's nothing to do there for this question. Remember, the last question was a double negative to sort out. Then we're going to look at the squared side. Now, it's 6 squared. That's going to give us 36. Then we're going to look at the 4AC. So 4 times 2 is going to give us 8. And 8 times negative 10 is going to give us negative 80. So we've got a takeaway, and then we've got negative 80. Now, if we had forgotten, we had 2 negative symbols, one from how the form is written and one from the calculation that gives us negative 80. What would happen here is that we have a negative number under the square root. And at GCSE, you're not going to be able to square root a negative number. So you're not going to get an answer, you're going to get an error. So if you do get a negative number, just have a look at it and think, did I miss something out here? Is there a way we can make this positive? Because we're only going to be able to square root positive numbers. Then at the end, the last thing to do is the fraction. It's 2 times 2, so it's all over 4. So let's simplify this and write it in third form. So it's going to be negative 6 plus or minus. So that's going to be 36 take away negative 80. A double negative gives us a positive, and it's going to be 116, and it's all over 4. So for substitution, we've got some marks, but now we need to write a final answer by actually writing this out. So we're going to have x is equal to negative 6 plus root 116, and it's all going to be divided by 4. And remember, the alternative, you'll lose a mark if you don't do this. As well as having the plus 116, there's also the minus 116 alternative as well. So you take the plus and negative symbols seriously. So typing that all into a calculator, open a bracket, type in negative 6, plus symbol, square root symbol, and 116. Close the bracket and divide it all by 4, and you should get x is equal to 1.19. And then it's 258. We're going to round to 3 decimal places, so 193. Then look at your calculator display, press the back button, go to the plus and change it for a minus and press equals. That will give you your alternative answer straight away, which is negative 4.193. And again, I rounded that, and again you can see we've got the same pattern of decimals occurring in both answers. Moving on to question 4, we're going to identify the value of A, which is 2, and swap any A's with 2. Find the value of B, it's negative 11. Swap any B's with a negative 11. Really important you include the negative symbol there. And then for C, it looks like it's negative 7, but remember it's on the wrong side of the equation. It needs to be next to the x term. So if we added 7 to both sides, it would actually be a positive 7. So swap all the C's with a positive 7. We're going to do 4 separate calculations here to simplify this. First, look at your minus b. It's minus 11. They're going to cancel out to give us a positive 11. Then look at your square symbol. Negative 11 squared, negative 11 multiplied by negative 11 will give us a positive 121. I'm going to take away from that 4 times 2 times 7. So 2 times 7 is 14. 14 times 4, 56. And it's all over our last section. 2 times 2 is 4. So in third form, we have x is equal to 11 plus or minus the square root of, now 121 take away 56 is 65, and it's all over 4. Now, if that 65 was a square number, like 64, then we can actually do the square root without a calculator, and we get 2 whole number answers. But because it isn't a square number, it's going to be a surd, it's going to be a repeating decimal, we're going to get 2 answers, we're going to have to round. So our 2 alternatives, x is going to be equal to 11 plus the square root of 65, all divided by 4, or the alternative answer is exactly the same thing with a minus on the square root instead. It's always a square root as a plus or minus alternative because there's always 2 ways to get a square number, multiplying the positive numbers or multiplying the negative numbers together. So type this into our calculator, open a bracket, 11 plus square root 65, close bracket, and divide by 4. That should give you x equal to, and to 3 decimal places, it's going to be 4.766. Then look at your calculator display, move back, change the plus into a minus. If your calculator can't do that, then you have to write the whole thing out again. So it does save a bit of time to have one of the better calculators. You should get for the second alternative 0.734. Now this time I notice the decimals are different, perhaps something to do with them both being positive numbers this time, whereas the last couple of questions, one was positive and one was negative. Interestingly, look at the decimals and a 3, 4, and together they're going to make 100. So again, we kind of got patterns happening with the decimal numbers here. And now moving on to the last question, speeding up a little bit, substituting A, which is 6, 2 places substituting A, substituting B, which is -6, 2 places substituting B, and then substituting C, which is going to be a -2, 1 place for that to go. And yes, it is a 2 in the equation, but it's not written in the correct order. We need to take away 2 from both sides, have it be next to the x term. Now we're going to do our 4 calculations. -6 will cancel it to give us a +6. Second calculation will be a squaring. -6 squared. 6 times 6 is 36. So -6 times -6 is also 36. Third, I'm going to do the 4 times 6 times -2. So 4 times 6 is 24. Times it by 2 will be 48. Now be very, very careful with the signs here. There is a negative included in the question, but then we've got -48 as our answer as well. And fourth, with fraction, 2 times 6 is 12. Write it all out in third form, 6 plus or equals, and then we're going to do 36 take away -48. Again, a double negative will cancel out to give us a positive. So it'll be the square root of 84, all divided by 12 in third form. However, we don't want the answer in third form. We've been asked to write it as a decimal. So on your calculator, we're going to have x is equal to 6 plus root 84 divided by 12 and 6 minus root 84, all divided by 12. That'll give you 2 answers. The first answer is x is equal to 1.264 to 3 decimal places. Again, irrational number. The decimal places do continue. And the other answer is going to be x is equal to -0.264 again. Now we've covered 3 different ways to solve quadratic equations. You can look at the factors and factorize, as we did in a previous video. You can complete the square, or you can use the quadratic formula. There's also 3 different ways to write the answers. You can have whole number answers, or perhaps answers with simple fractions in, like halves and quarters. You can have it written in third form, where it's completely accurate, you don't work out the square root. And then you can write it as a decimal, but that's less accurate as you have to round.